Today's lesson will be about Group 1 Alkaline Metals. There are 6 different alkali metals: lithium, sodium, potassium, rubidium, cesium, and francium. We will be exploring both Group 1 alkali metals as well as Group 7 halogen in this chapter. We will like to focus our study of these groups by exploring firstly their physical properties, chemical properties, trends, as well as their reactions. So let's first start with alkali metals. The physical properties of alkali metals. Alkali metals are in group 1 and therefore they have metallic properties. They have metallic properties and therefore they are shiny. Metals are known to be shiny. However, the interesting thing about alkali metals is that they have very low density and they float on water. Low density and float on water. They are also very soft and can be cut by scissors or a knife. So they are very soft. Alkali metals, because they have one valence electron, also are very reactive. So they are very reactive and will react readily with water, air, and acid. They lose their one valence electrons easily to form a positive 1 ion. So these are the physical properties and chemical properties of alkali metals. Also, in periodic table, it's important for us to understand the trend in the group. So when going down the group, that means from lithium, sodium, potassium, rubidium, cesium, francium, this is called going down the group. We will investigate the melting point, the reactivity, as well as the density. As we go down the group, the melting point of alkali metals decreases. Lithium is a solid, sodium is a solid, potassium is a solid, but rubidium can be turned to a liquid by holding it in your hand. Cesium and francium too are liquids. So the melting point of alkali metals decreases down the group. Next, the reactivity of alkali metals. The reactivity of alkali metals increases down the group. The reaction of lithium and sodium in water is vigorous, but the reaction of potassium in water is explosive and the potassium will catch fire. Rubidium, cesium, and francium are extremely violent and cannot be carried out in a proper lab. Next, the density of the metal increases down the group. This is very interesting because although rubidium and cesium are liquids, they are of higher density than potassium, sodium, and lithium. So, we have been talking about the reactivity of alkali metals. You must be wondering, what type of reaction are we talking about? The reaction of alkali metals that we are interested in is the reaction of alkali metals with water. So the alkali metal plus water will give us the alkali plus hydrogen gas. So for example, lithium will react with water to give us the alkali, which will be lithium hydroxide plus hydrogen gas. This reaction can be easily balanced. So this equation can be applied to all the alkali metals. For example, potassium will react with water to produce the alkali potassium hydroxide plus hydrogen gas. Again, because this is in the same group, it can be balanced the same way as well. Okay, so we would like to quickly go through and summarize what we have did today. Physical properties of alkali metals. They are metals and therefore are shiny. However, they are of low density and they float on water. Alkali metals are also extremely soft and can be easily cut. They are extremely reactive because they have only one valence electrons, and because of that, they form positive 1 ions. As we go down the group of alkali metals, their melting point decreases, their reactivity increases, and their density increases. The reaction of alkali metals that we need to know is that alkali metals plus water gives me alkali and hydrogen gas. For example, lithium plus water gives me lithium hydroxide plus hydrogen gas. So if we do this summary in a table of the trends, we can see for alkali metals, as we go down the group, the melting point decreases, the reactivity increases, the density also increases. Now, please stay on to watch an interesting video about the reactivity of alkali metals. Thank you.
There are 6 alkali metals: lithium, sodium, potassium, rubidium, cesium and francium. They're all soft metals which can be cut with a knife. In air, the elements quickly become coated with compounds that form on the metal's surface. Here, for example, is lithium. When we slice it, you can see the metallic luster, but the black coating quickly reappears. Sodium is kept under oil to prevent reaction with air. Again, when we cut it, the metal surface can be seen. But this time, corrosion occurs even more quickly. With the next alkali metal, potassium, the corrosion in air is so quick that it's hard to see the metallic luster at all. As we go down the group, the elements seem to react more quickly with air. Now let's see another reaction of the alkali metals, the reaction with water. We'll start with lithium. The metal floats on the water and reacts with it, giving off hydrogen gas. Now for sodium. The same sort of thing happens, although the reaction is a bit more vigorous. All the alkali metals react with water in the same way. Let's see an equation for the reaction. Hydrogen gas is produced, and the metal dissolves to give an aqueous cation with a single positive charge. Now for potassium. This time you'll see a flame. The heat given out by the reaction is produced so quickly that the hydrogen gas catches fire. It burns with a lilac flame. The next element is rubidium. This time we put a safety screen between us and the reaction. You can see that things gradually become more terrifying as we go down the group. Let's try cesium, our 5th alkali metal.